Okay, today we're going to talk about how we program a computer. So, in our last lesson, we talked about the operating system and the role the operating system plays. Okay, but what we're going to explore today is how would you create an operating system? How would you write your own operating system? Okay, but not just operating systems, but we can actually think about how we can write our own programs to get the computer to do what we want it to do. Okay, so we need to go right back to basics, and we need to think about the language that the computer understands. Okay, so the language that the computer understands is based on electricity. Everything your computer does is done by circuits, electrical circuits. Okay, now if you think about an electrical circuit, it basically uses electricity, and electricity has two states, on or off. Okay, so the language of a computer, which we learned about before, is binary. Okay, so binary is just a sequence of ones and zeros. Okay, so the language of your computer is binary code. So the fundamental, the main way that you could write a program for your computer would be in ones and zeros, would be by directly programming it in ones and zeros. Okay, now we call this code, we call it machine code. Okay, so I'm going to draw a diagram here, and I'm going to put an extra layer on here, and our first layer is going to be machine code. Now we say that this is a first generation language. Okay, it's a first generation language. There we go, a first generation language. So machine code is just the ones and zeros that you can use to directly program your processor. Okay, and so if you're writing in machine code, you're writing instructions that your processor can understand. There we go. Now, you can, if you want, you can write machine code programs in machine code. You can write programs in machine code. You can, if you want, write programs in machine code. But if you think about it, machine code is ones and zeros. So it wouldn't be easy for you to read it. It wouldn't be easy for you to debug it. It wouldn't be easy for you to find mistakes in a sequence of ones and zeros. So it'd be very difficult for you to use. Okay, so when computers first came about and people were programming them initially in machine code, they realized that these were problems. These were things that were going to stop people from programming computers. It was going to be really, really difficult to program a computer because it's very difficult. Imagine trying to read lots and lots of ones and zeros and trying to spot a mistake. You know, a one where you should have put a zero in all of those ones and zeros. Okay, so they needed an easier way to program their computer. So what they did was they came up with a second generation language. Alright, so they moved up to a second generation language. Now, that second generation language is called assembly code. Oops, sorry, I can't spell today. Assembly code. Okay, now, all assembly code did was take some of those ones and zeros and give them mnemonics. Okay, give them words that represented those binary codes. Okay, so for example, we might take the binary code for load and we might replace it with the word load. Okay, so that would be an assembly code instruction. We've just taken some binary codes and we've given them mnemonics, we've given them names, or we've given them words to represent that binary code. Okay, now all of a sudden when you start doing this in a second generation language, we are no longer writing instructions that the processor can understand. Okay, so when we start writing instructions in assembly code, although the instructions is one machine code instruction to one assembly code instruction, we still need to translate them. Okay, so to translate our assembly code instructions into machine code, we need to use something, and I'll put a little arrow to show that. Okay, so to go from assembly code to machine code, we need an assembler. Alright, so an assembler, all it does is it translates those English words, those mnemonics that we've used to represent those machine code instructions, and it just translates them into machine code instructions. Okay, now, so between assembly code and machine code, there's a one-to-one relationship. Okay, now, why would you code in assembly code? Well, it's easier for us than machine code, isn't it? Okay, if you can see mnemonics, if you've got mnemonics, it's going to be easier for you to debug. It's going to be easier for you to read, and it'll be easier for other people to read. Okay, but also, if you code in assembly code, you're coding using instructions that are directly accessed by the processor. Okay, so that's going to be faster, and that's going to be more memory efficient. All right, so programs that are written in assembly code tend to be executed faster by the processor, and they also tend to take up less memory, which are two really big advantages for writing programs in assembly code. Okay, they use up less memory and they run faster. Okay, now if you think about programs that you want to run really fast and maybe you don't want to take up huge amounts of memory, an operating system would be one that you want to run fast and you don't want it to take up huge amounts of memory. So we tend to write operating systems in assembly code. Okay, computer games are also, obviously we need to optimize those to run as fast as possible. So computer games tend to be written in assembly code, okay? Because assembly code, those instructions tend to run faster and they take up less memory, all right? So, and there's a one-to-one relationship between our assembly code instructions and our machine code instructions. So although they take up less memory and although they run faster, it's harder to program in assembly code because there's only a one-to-one relationship between the assembly code and machine code. Okay, so because it's still quite hard to write programs in assembly code, what a lot of people did is they created a third generation of languages. Okay, now there are lots and lots of different third generation languages. A perfect example of a third generation language is the language that you're learning, which is Java. Okay, but you may also have learned Python, which is another example of a third generation language, or C++. And there are lots and lots of third generation languages. Okay, now third generation languages are designed to make it easy for you to program the computer. So what they've done is they've taken like several of these machine code instructions and they put them into one third generation language instruction. So what we say is the relationship is one to many. Okay, so one of these third generation language instructions is actually worth many machine code instructions. That means it's much easier for you to program the computer in a third generation language. Okay, and a third generation language also is much more like the kind of language that we use every day, which makes it much easier for you to code in that language. Okay, now obviously what's really, really important is that although you understand a third generation language, it's easier for you to understand, the computer doesn't understand it at all. Okay, so what we need to do, like between the assembly code and the machine code, we need an assembler to translate our assembly code to machine code. Okay, we need something to translate our third generation language instructions into machine code or first generation language instructions. Okay, now there are two things we can use to translate third generation language instructions into first generation instructions. And I'm going to draw, I'll put my line across here. Okay, so to go from third generation to first generation, we can use either a compiler. Okay, so we can use a compiler, or we can use something called an interpreter. And in a later lesson, we'll talk about the difference between a compiler and an interpreter. But for today, all you need to understand is that we can use a compiler or an interpreter to translate third generation language instructions back into machine code or first generation language instructions. Okay, so before the computer can execute our third generation programs, we must use a compiler or an interpreter to put it back into machine code. Okay, now why would we write programs in a third generation language? Well, it's much easier for us to do. As we said, our programs are less complicated than they would be in assembly code because one of these instructions in a third generation language is worth many of these. Okay, but they will take up more memory and they won't run as fast as these assembly code instructions. So it'll be easier for us to understand this third generation language, but they will run slower and they will take up more memory. Okay, but another advantage we get from Java is the fact that programs that we write in a third generation language tend to be more portable. So when you write in a second generation language in assembly code is designed specifically for that CPU, that processor that you are using. So if you want to create a game, you have to design it specifically for that processor if you're going to write it in assembly code. Okay, but in a third generation language, the processor is less important. You use a compiler or an interpreter to turn it into instructions for that particular processor or CPU. So these programs written in a third generation language, we say they are portable, that you can take them and you can use them on different computer systems. So for example, Java programs are a great example of that. As long as you've got the Java virtual machine installed on your computer, you can, when you write your Java programs, you can take them and you can use them on a Windows machine, or you can use them on a Mac, or you can use them on any type of computer, as long as it's got the Java virtual machine. So you don't have to make any changes to your Java programs. They'll run on any different kinds of computer system. Okay, so third generation language programs are far more portable than programs written in first or second generation language. Okay, so this has also been to do with how to program a computer, and hopefully you understand the different generations of language, and more importantly, you can understand when we use the different generations of language. Okay, so assembly code, fast, memory efficient. Okay, so programs are small and they run very quickly. Third generation programs are much easier for us to understand, they're much easier for us to write, but they take up more space and they won't run as fast, but they are portable. Okay, thank you very much. Next lesson we're going to talk about the difference between a compiler and an interpreter.